Welcome to another tutorial in MATLAB Tech. In this tutorial, we will be looking into different types of subsystem and how it is being used in MATLAB. We will try to understand the detailed concept about three different type of subsystem. First is the enable subsystem. Then we will be having a look into triggered subsystem, and then we will have a look into enabled and triggered subsystem. So we will also try to find out what is the difference between these three types of subsystem. So before this, we need to understand what is basically a subsystem. So let's try to understand basically what is a subsystem. So coming to a subsystem is a function block. You can consider it as a function block. So for example, in this case, you can consider a up counter. So basically, whenever you want to do counting up, right? So suppose you want to do up counting like this, then you need to implement a up counter in this case. But suppose if you want to implement a down counter, suppose it is counting down, then in that case you will be needing a down counter, right? So basically it will start with a higher value and it will end at a lower value. And for the up counter, it will start with a lower value and it will end in a higher value. So these are different type of functionalities. So one could be up counter and one could be down counter, right? You can enclose this within a box, which is basically called subsystem. So this is called a subsystem. Okay, so this is basically called a subsystem, and using subsystem, we can either make it enabled or triggered or enabled triggered. So all the varieties we will see in this particular video. We will also implement it in MATLAB, so stay connected till the end of the video. We will try to analyze how these things works in the MATLAB environment. So to go into the details, first we need to understand what are these subsystems are behaving in MATLAB environment, and then we will go analyze in the MATLAB environment, are they exactly behaving in the same way or not. So first we will look into this enable subsystem. So if you consider an enable subsystem, then you will have input, right? So these input which you are able to see, this is the enable signal which we usually call, and whenever this signal is 1, right? So whenever the signal value is 1 from 0, right? If it is previously 0 and now it is 1, so whenever it becomes 1, right, at that moment you will have the calculation whatever you designed inside the system gets triggered. So in this case, suppose you designed an up counter, right? So the output response will be somehow like this. Okay, so this is how you will get the response. But suppose you got first 0, then 1, then 2, and then 3. Now your subsystem input signal became 0, right? So now it is 0 at the end. So at that moment, what will basically happen? So it is more important to understand that part as well. So whenever your enable subsystem get disabled, like the enable signal is now 0, right? So in that case, whatever the value that you hold at the last, right? So that will be held, right? Suppose you counted up to 3 and now your signal for the enable got disabled. So you will have 3. Again, if the signal getting enabled, then what will happen? The count will start from here, 4, 5, and then 6, right? This will be 4, 5, and 6. It will not start from 1. Okay. So this is one condition where you can give the detail of it. There are multiple features you can activate in this particular subsystem. Suppose you want to reset also, you can do that by implementing it inside the subsystem. But this is the default behavior that you usually see in designing any subsystem. So it holds the previous value. And in case of enable subsystem, it only gets triggered, or the calculation only gets triggered when the value is 1. Okay. Next is the triggered subsystem. So in case of triggered subsystem, you will have two options. One is the rising edge, another is the falling edge. Okay. So when the value is rising from 0 to 1, then at that moment you will have a calculation get triggered. So in that case, you can consider it as a rising edge triggered subsystem. Okay. So there could be one more possibility. If a signal is rising, then definitely after some time it will fall, right? Or it may not fall. But whenever it is falling, right? So at that moment you will have a transition between 1 to 0, right? This is called a falling edge. At that moment, this calculations get triggered. There could be two more possibilities. Like you can combine these two, like the rising edge and the falling edge, and you will have it like whenever the signal is rising like this, then you will activate the signal or the calculation. So the calculation inside this will get activated, and whenever this signal is again falling down, right? So at that moment also you are calculating the signal. So suppose one case could be like you have counted up to 2, right? 0, 1 and 2, right? So how this happened? So first the rising edge will be calculated, right? The first one. So the transition happens from 0 to 1 in this case, right? Whenever this falling edge happens, then one more count happens. In that case, you will have like 1 to 2. So that is how you are getting this 2. Okay. So this is how a triggered subsystem works, and it has two options, totally three options. So either you will have a rising edge, or you will have a falling edge, or you will have rising and falling edge both. Okay. So the last pattern that you have is the enabled and triggered. So here both part are there. So one will be enabled and another will be triggered. So in this case, suppose you consider the enable signal is this one, and the trigger signal is this one. So the situation is like this. So whatever the enabled and the trigger that you have, right, both will be ANDed. So this will be ANDed. If the outcome is 1, then only you will be getting the response or the calculation from the subsystem. So suppose your signal is enabled, now it is on, right? And along with that, suppose there is a transition that happened from 0 to 1 for the signal 2. Then in that case, the calculation will get triggered. Okay. So this is a triggering condition for the calculation to get activated. So in case of the enabled and triggered subsystem, we do have some choices. Okay. So first is the enable one, which will stay as it is, because the enable cannot be have multiple varieties. But in case of the rising and falling edge and both the edge, so what you can have this one fixed, and you can add either rising edge, which could be the behavior for the second signal, or you can add the falling edge, which could be the behavior of the second signal again, but here you will have only enabled signal. And the third possibility is you can have both the edges, like falling and rising edge, along with the enable one, right? So that is how you can design this based on your requirement. And here also, whenever this calculation is getting triggered and you are getting an output, suppose you got the output from the calculation as 3, then this will be held, and you will be able to continue the calculation from this value itself. Okay, so this is how basically we seen in this case like enabled subsystem, and we also seen the triggered subsystem, and we also seen enabled and triggered subsystem. Here in the case of enabled subsystem, we will have one signal as an enabled signal. Here in case of trigger subsystem, we have one signal as triggered signal, and here we have two signals. So basically when you use a enabled and triggered subsystem, you need to use two signals to activate the system. Okay, so subsystem gets calculation based on these inputs, and then it gets triggered and it implements it. Okay, so in this case in the implementation part, we will be looking into the concept related to fault calculation. So we will be considering a fault calculation, and we will be using that to determine like whether the fault is there, how much time the fault is there, and whether the fault is resolved or not. So these many implementation we will see in this particular model implementation, which we are going to do in the MATLAB environment. So let's jump into that. So let me explain the model, then we will be going further details into the subsystem. The model that we have is a fault system. So whenever I am having any fault, then the input to the system will be 1. If I am having no fault, then input to the system will be 0. Okay. So in this case, I can transit it from 1 to 0 or 0 to 1 by using this manual switch. So you can use a manual switch to transit between 0 to 1. Okay. And in this case, you have this fault system. So let's try to look into what is basically this fault system. So in case of this fault system, you can implement this using state flow. To see the details of the state flow, you can check the state flow playlist that we have, and based on that you can implement this. So in this case we have two states. One is the regular operation state and another is the fault detected state. So whenever this f is 1, right, so it is being compared and this transition happens and it goes from regular operation to fault detection or detected state. Again, whenever you are in a particular state, a particular variable will be sent out as an output. So basically a fault detected output is sent. So here in this case, the fault detected is 0. And here in this case, the fault detected is 1. And this transition can only happen with the variable f, which we are using as an input from outside. So suppose I want to see the simulation, which state is basically active, then I can step, and with this you will be able to see the simulation started, and you will be able to see it appeared in the regular operation. This is the default transition, so that's why it is starting with this one. You can start with this one as well, but it is always recommended to have a regular operation as a default state, so that you can implement it in representing a particular scenario. Okay, so in this case we are in the regular operation, and here you can see the fault detected variable is 0. And outside also you can see the fault detected variable is 0. This we are sending as an output. Okay, then if we introduce a fault, right, then in that case we need to switch this to 1. So it is already in 1. So if we step again, then we will be able to reach to the fault detector state, and here the fault detected variable is 1. So this is a simple implementation which we are using to understand what is basically happening in the enabled, triggered, and enabled triggered subsystem. Okay, so here we will stop the simulation and try to analyze model one by one. So let's step again, and here we will be transitioning from to 0. Okay, because we are considering that system has no fault at the initial stage. So now we will just click on the signal lines and we'll see the values live. Okay, so these are the values that you can see live if you just click on the signal lines. This will only happen if you are running in the step mode. Okay, and you can also see the input signal. Okay, so now we will just step, the signals got updated, right? So there is no fault in this case, and the fault outcome is 0. So you can see the triggered subsystem gets 0 as the output, and enable subsystem as well, and also the triggered subsystem. So we do have two triggered subsystem. One is for the rising edge and another is for the falling edge. Okay, this one is for rising edge and this one is for falling edge, and all these subsystem implements a specific calculation, only counting the number of events that is happening. So it will get updated every sample time. If we double click over here and see the implementation. So this is a basic counter logic which you can see. So we have a constant, we have a adder block, and we have a delay, and the output is coming this way. Okay, and this is the sign for the triggered block. Okay, if you just double click over here, you will get multiple options, right? So rising as, falling as, either as, or it can be a function call. We will see the function call later on in the future videos. Along with that, we will also see the either as also in the later videos. Okay, so coming to the other subsystem, here you will have the same things available. So here we are using a held or reset. So here you can choose whether the value should be held or a reset. Okay, so if it is reset, then the output will be set to 0. If it is held, then output values will stay as it is. Whenever the next subsystem gets triggered, right, then it will start from that value which we discussed in the previous slides. Okay, and you will also have now one more subsystem, which is the falling as subsystem. You can see the arrow, so it is falling. Along with that, we can also get these options which we discussed already. Okay, so these are the subsystem, and the calculations implemented in these subsystems are the same, nothing specific different in individual subsystems. Okay, so let's start the simulation and introduce a fault. So I started. Okay, now the fault is 0. Here outcome is also 0, and no enable or triggered is getting activated. So now we will switch and give the first fault. Now if I step, then I'm getting the first fault, and there the triggered subsystem got activated, and it gives a count as 1 because it is rising from 0 to 1. Previously it was 0 and now it is 1. So that's why this event got counted, and you are getting the fault detection. So whenever there is a fault detected, then this will get activated. Whenever a fault is being removed from the system, this will get activated. And if the system is inside the fault, then this subsystem will calculate like how much time it is inside the fault based on the sample time. So every sample time it will increase, and based on that you can implement it. So coming to the analysis for the fault counting subsystem. So here we have one fault detected. Now the fault is still there, and if we step again, the count value over here is increasing. This is happening because this is an enable subsystem. Whenever the value is 1, this calculation will always get triggered, and because of that you are getting this output. So whenever I'm stepping, yeah, we are getting increased in the value, right? So it is now having 4. So 4 into the sample time you can multiply, and then you can get the actual time. But here we are just counting how much sample time it is having the fault. So 4 sample times it is having the fault. Now if I step, then again it is increasing. Okay, so now let's remove the fault, right? So now we removed the fault, and now if I step, then you can see the value is staying as 5. This value stays as it is because now it is deactivated, but we have selected the option for held. And over here, what you can see, the falling as got detected, right? Initially it was 1, now it is shifted to 0. And because of this, you are getting a event that is the falling as triggered event that got triggered over here, and that triggers this calculation, and you are getting 1 as the output, right? So that is how you are implementing this falling edge triggered, and you are getting this output, right, as 1. Now whenever this fault got recovered, then only this calculation becomes 1. So in this entire system, whenever a fault is detected, the first subsystem will get activated. Whenever the fault is already there in the system, then this particular count value increment. Whenever the fault is being recovered, then in that case, this particular subsystem will start the calculation. So let's see these things are happening or not. And we have selected the held value for all this subsystem, so that whatever the output that is there, it will be held, and from that the count will only get triggered. So let's step. So there is no increment in the second fault counting calculation, because fault is not there, right? So now we will switch back to the fault again. Okay, now this value is 1, and here we counted 2 faults got detected in the system, and here only 1 fault got resolved, right? So 2 faults detected, 1 fault resolved. So overall in the system there is 1 fault existing. Okay, and this counter will again increment. Okay, and you will see the count increasing. Okay, so this is telling you like how many sample times you were having the fault. So overall you are having 12 sample times which is having the fault, and that is how you can implement this. So suppose you want to make like whenever the fault happens, then only you will start counting, and you will start counting from 0. So in that case you will just change it to reset. Okay, and then let's do the simulation again. So I will keep it as the default one, no fault. I will make all these system inputs as 0. And then what we will do, we will step one more time. And as you can see, there is all are 0. Now we will switch back and we will get the fault and step. Okay. So now this is detecting the fault. Fault is not yet recovered. This starts counting, right? So you can see this is counting. And now when I am removing the fault, this will increment and this will reset to 0 because we have selected reset, right? And this will stay as 1. Okay, so this is 0. So this output should reset. Okay, so this will get reset only when it is calculating for the next time. Okay, so let's enable the fault again. Okay, and then if we start the simulation, then this will become 0. Let's see. Yeah, so it started from 0, and as there is a fault, right, it started from 1. So with this implementation, what you can do is like you are detecting a fault, you are also detecting whether the fault is recovered or not, and you are calculating like how much time it is inside the fault. So if we do again, right, it is starting and counting. Okay, and whenever we are switching back, it is holding the previous value, right, 20, and it is holding the value for the longer time. And whenever we are switching back to again the fault state, it will start from 1, right? So this is a simple implementation of a fault detection and mitigation mechanism implemented in MATLAB. As we need to understand how these things are implemented in a realistic environment, so it is very important to implement it in a real scenario. So we understood it in implementing a real scenario, and we tried understanding how the subsystems are used basically, and how we can count faults. So in summary, we've seen what is basically a enabled subsystem, what is basically a triggered subsystem, what is basically a enabled and triggered subsystem. Along with that, we took an example to understand how faults can be detected through the use of the subsystem, and we can also check how much the interval for the fault based on the sample time. So in case you are liking the channel, please consider subscribing. In case you have any comment or query, please let us know in the comment section. We will be more than happy to clarify your doubts. Have a great day ahead. Thank you.